So we have our bonus chute in our game, but right now it's not really acting like much of a chute. As you can see, if I launch any balls into the playing field, they bounce right off the top of it instead of, say, going through this giant hole in the center, which we would probably expect it to do. So maybe you're wondering, why do we bother putting this rectangle in the middle of our chute in the first place? After all, that's what's causing these collisions, and maybe if we got rid of it, we could do some fancy point within rectangle checking every frame to see if our ball passes through this space where the hole should be. Well, it turns out we don't have to do that, and the reason I put this rectangle in the middle of our chute is that Box 2D has a way of defining a shape in a way that it still exists in our world, but it's like a ghost object. Other objects can pass through it without really colliding, without it affecting the object's motion. However, because it still kind of exists in the Box 2D world, it still registers a collision within our contact listener, and we can basically use that to detect the collision. And the way you do all of this magic is just to define this shape as something called a sensor. And so we're going to go to our bonus chute and try that right now. And it's actually very easy. Box 2D lets you define objects as sensors on a shape-by-shape basis. So what I can do is, within my bonus chute actor, I can define my left and right ramps as normal tangible objects that balls will still collide off of. But I can take this center hole shape and I will change the definition so that isSensor is true. So now I've basically defined this as a ghost object. And that's actually kind of all I need to do. If I run it, let's clear out a few of these pegs here. And you'll see that when the balls hit the bottom, they bounce off the sides, but now they're going right through where the center used to be. Now we still don't have quite the right logic here because the ball is passing through and it keeps going. And probably what we want to do is detect that our ball has collided with the center of the chute, make the ball disappear right away, and probably display some type of, hey, congratulations, you got a bonus ball message. So let's move on to the next step. This, it turns out, is also fairly easy. Do you remember how I showed you to set user data and get user data for, say, a body so we could point to the actor? Well, in addition to doing it on a body-by-body basis, you can do it on a shape-by-shape basis. So maybe what I'm going to do here is I'm going to define a constant that we'll call bonus target. And then I'm going to go back down here, and right underneath where we set sensor to true, I'm going to set our user data So now I've set my arbitrary bit of user data within this shape as a string that basically just says bonus target. What will that let me do? Let's find out. I'm going to jump into my contact listener. So within our contact listener, it looks like we've detected whether a ball has run into a peg. What we can also do is check and see if any objects involved in the collision include our bonus target. So first thing we'll do is we'll check and see if shape 1, and remember I don't have to get body here because I'm actually looking at the shape. So if it's a string, I do this first because then I can basically cast our user data and see if it equals our bonus target. And maybe just to be safe, we'll make sure that the object that's collided with it is actually a ball actor. Right now there's nothing else that would really be colliding with this thing, but you know, better safe than sorry. And so right now I'll just throw up a trace statement. And remember, we're never guaranteed that any two objects in a collision will necessarily be assigned to shape 1 or shape 2. So I have to run this whole check again, just with shape 1 and shape 2 reversed. So if shape 2 has user data that's a string and it's equal to bonus target and shape 1 is a ball actor, then we also know the ball hit the target. Now let's run this here and see if it works. So we'll launch a few balls into the world. As they go down, it looks like. All right, a few of them are intersecting with our rectangle. And it looks like when they hit our target, we are getting a ball hit target message being displayed in our output. So that's pretty good. Of course, sending off a trace statement in the contact listener probably isn't what we actually want to do. In a real game, we'd probably somehow want the main application to know so that we could increment the inventory and give the player some bonus points and display a nice message on screen. So let's kind of go through what that might look like here. I think maybe the way I'll do it is in our ball actor, I'm going to create a function called hit bonus target. And within our Puggle contact listener, instead of putting in this trace statement, what we can do is we can say our point shape 2, get body, get user data, hit bonus target. And we can do the exact same thing down here, except that we'll be looking at shape 1. And then within our ball actor, what we probably want to do is find a way of letting our main Puggle class know that, hey, this ball has hit a bonus target. So let's do that by creating another ball event. So we've got our ball off screen. Let's create one called ball hit bonus. And now within this hit bonus target function, I can just dispatch an event. That's a new ball event called ball event ball hit bonus. All right, so far so good. And then finally, what we can do is in our Puggle application, when we create a new ball, in addition to listening for ball off screen, let's also listen for ball hit bonus. And we'll call handle ball in bonus shoot. Now this is the point probably in a real application when I would say display some fancy special effects on screen and I would play some sounds and I would increment the player's inventory. However, in this case, maybe I'll just bring back the trace statement. And then at this point, I think we actually just want all the same behavior as if the ball had moved off screen. We want to remove our ball. We want to safely remove the actor, and we want to remove any pegs that have been lit up. So I'm actually just going to call handle ball off screen. I can even pass in the same event. Crazy, huh? The only other thing I should do, just to clean things up, is when we remove the event listener for ball off screen, we should also remove the event listener for ball hit target. Or sorry, ball hit bonus. Okay, so just to review, within our Puggle contact listener, when I've detected that a ball has collided with the bonus target shape within our bonus shoot, we're going to call the hit bonus target function on the ball, or on the ball actor, I should say. That will dispatch an event called ball hit bonus. Our Puggle class will listen for that, and when that happens, it will call handle ball and bonus shoot. That for now will just display a trace statement and then remove the ball as if it had fallen off screen. Now if we run all of this, we'll launch a few more balls into the world. And we can see two things happening here. One is that in my output, we are getting the correct ball hit target message. The other thing is, and maybe it's hard to notice in my screen capture, but you'll probably notice it at home, is that my ball disappears immediately when it hits this rectangle with my bonus shoot. It doesn't continue falling for those other few pixels to go off screen. So it actually gives you the illusion that the ball is going through this hole in the middle of our bonus shoot, which is pretty cool. And it is still bouncing off the sides like you would expect it to. So there we go. We got our bonus shoot in and working, and it's now detecting that the ball is hitting the middle of it. All we have to do is the simple task of moving it left and right. And we'll take care of that next.